Video 127 Part B. Now, in video 127 Part A, we actually ended at this problem, but I went ahead and retyped it and changed this to a minus sign. Let's pick up where we left off and continue. What you got here is this. We decided to call this an a squared minus 8a minus 9. What we've done is we've basically made a substitution. We said that capital A equals 2a plus 3. Then, when we factor this easier looking trinomial, we're going to have a minus 9 times a plus 1. Okay? Temporarily, this is where we're at in the game, except this is not the correct answer because we're not asked to factor a trinomial that has capital A in it. We're asked to factor the one that's got the lowercase a, or x, or whatever this would have been. So we're going to go back and resubstitute here. So now we can change this to 2a plus 3 minus 9 times 2a plus 3 plus 1. Here's the substitution. Then we just simply combine like terms. We get 2a minus 6 times 2a plus 4. Then, of course, we can actually take out a 2 from here. That'll give us 2 times a minus 3 times, take out another 2. See what I did there when I had to put a squared here? So, of course, we can finish it off as 4 times a minus 3 times a plus 2. And this would be the factored form of that trinomial. Pretty interesting how it all happens. Now, this step here might not happen every time because you might not have any common factors. In fact, you probably won't. But it did happen this time, so no big deal. We'll just take care of it. Alright, let's go to the next one. This would be factoring by using what's called difference of two squares. Now, before we take a look at this, let's take a look at a simple pattern. Okay? X plus 3 times x minus 3. If we were to go through the FOIL process, or the distributive property process, there's your first term. Your outside would be minus 3x, inside plus 3x, last minus 9. Look what's happening. That goes to a 0. You're simply left with x squared minus 9. So this and this are the same. If we did one more, just for grins here, let's say you did 2y plus 5 times 2y minus 5. Well, you're going to get the same situation. The middle terms are both going to be what? 10y minus 10y. So you might as well just go right here. Well, what is this? That's the first term squared. So you'll have 2y quantity squared minus 5 squared. So you're going to end up with 4y squared minus 25. We can use these patterns to help us go in the multiplying direction or the factoring direction. So you can multiply and you can factor. So what we'll do is we'll go ahead and break this down into the squares. Let's call this 4x quantity squared minus 9 squared. Now, judging from what we just did here, okay, we actually have a formula. A minus b times a plus b is simply a squared minus b squared. So, we can then call this simply what? 2x minus 3 times 2x plus 3, and you go home a winner. Next one. Oh, blank page. Here you go. 25x to the 6 minus 100. Let's break this down into the difference of two perfect squares. Let's call this 5x cubed squared minus 10 squared. Reverse engineer it. That's how you do this. Does this step equal this? Well, then we just did something that's correct. Is this the difference between two perfect squares? Of course it is. And I can call this 5x cubed minus 10 times 5x cubed plus 10. And that's it. You're a winner. Nice job. Next one. Now, is this the difference between two perfect squares? No, because there's no minus sign. But maybe we can create one. Now, we can do it here because this is a minus. Essentially, we're going to reverse this. There's two ways to do this problem. We'll go ahead and do it the two different ways. Let's go ahead and divide this up into two pieces here. The first way would be to take a negative out. And you can call it x squared y squared minus 64, and then from here the answer is pretty obvious. We're simply going to have a minus, right? And we're going to have xy minus 8 times xy plus 8. Just like the last one, except just have a minus sign in the front. Another way to do this is to rewrite this as 64 minus x squared y squared. This is still workable. Now you don't need to take a minus sign out. You just call it 8 minus xy times 8 plus xy. So either way, you're a winner. Nice job. Here we go. Factoring by the difference of two squares. This might not look like it is, but if you recall, this is a perfect square trinomial. Okay? So what we're going to do is we're going to call this 25y squared, and we're going to reverse engineer it. Minus what? What would you put in here to make it look like the first step? Well, that would be a positive 9 now, wouldn't it? Because it's got a minus in front of here, right? What kind of 6x is that? That's a positive, so we're going to have to make this a negative 6x. And in order for us to distribute a minus, this would have to be a regular x squared. Okay? So if you distribute the minus here, you'll end up at the first step. Now, this is a perfect square. And if you take a look at my videos on completing the square, which I'm going to do another one here soon, probably video number 128, completing the square. So it'll be called factoring by completing the square, but the pattern is this. Whenever this number divided by 2 squared is that, then you have what's called a perfect square trinomial. So what we can do is we can call this 5y quantity squared minus, get that out of the way. This ends up being x minus 3 quantity squared. And if you run the numbers out, you'll see. And obviously there's a lot of YouTubers. You can always check to see how to factor by completing the square if you don't like the videos I've had so far on this. And then now look at this. Difference of 2 perfect squares. So let me just call this 5y minus and 5y plus. 5y minus what? X minus 3. 5y plus x minus 3. Now one of those parentheses is unnecessary. Which one? That one with the plus sign. Because plus signs distributed are the same thing. But the minus sign would be necessary here. So you could actually leave your answer here in the factored form, or you could distribute that minus and put it as 5y minus x plus 3 times 5y plus x minus 3. I prefer this answer as an instructor, but either way is fine. Okay, next one. Factoring by using the sum and difference of two cubes. Guys, here's the formula.